Hello, calculus students. Here's our next lesson. Today we're going to learn about this old Frenchman named L'Hopital. L'Hopital, something like that. I don't really know how to pronounce it. Guillermo de L'Hopital. We're going to learn about a rule from him that is going to make things so nice and easy. Now, in some textbooks, you're going to see it called La Hospital's rule, because I guess this is like the anglicized version of how to say this. I don't know how to pronounce it here. I actually pulled this up on Google Translate so we can learn how to pronounce it.
Guillaume de l'Hôpital. Guillaume de l'Hôpital.
Okay, that's not on any test,
Guillaume de l'Hôpital.
but it's just cool. It sounds awesome. La Hopital, or La Hospital's rule is going to be great for us today. So let's recall some things. First, special trig limits. You remember how if we had a limit that x approaches 0 of sine x over x, that equals 1? Okay, so we remember that. And then if we have 1 minus cosine x over x, that limit as x approaches 0 equals 0. What we're going to learn today is if you forget this, there's actually the L'Hopital's rule helps us to be able to figure them out really quick. Now, also remember that when we're evaluating limits, we first need to try direct substitution. So that means if x is approaching 3, we just need to plug in a 3. So it's going to be 2 times 3 minus 5 all over 3. 6 minus 5, so the answer to this is 6 minus 5, 1 over 3. Okay, that's it. We don't need to do anything else. So in example 1, let's try this. Direct substitution. What is that going to become? 2 squared is 4 minus 7 times 2 is 14 plus 10 all over. X minus 2 is 2 minus 2 is 0. Oh, that's a problem. Let's see what else we get. 4 minus 14 plus 10. That gives us negative 10 plus 10. You get 0 over 0. Okay, so how do you do this one? This is where you have to factor things. You're going to get an x minus 2, and then whatever that is, x minus 5. X minus 2's cancel. Now you can plug in the 2. 2 minus 5, so it's actually supposed to equal negative 3. Okay, I know I did that really fast. That's the answer to that one. What we're going to show you with L'Hopital's rule is that there is a shortcut with this, which is awesome. And that is, if you end up with 0 over 0, or you get infinity over infinity, then you have a situation with limits in which you can use L'Hopital's rule, and that states that all you have to do is take the thing on top and take the derivative, and the thing on bottom and take its derivative, and then plug in a. Okay, so I'm going to repeat that. You just take the derivative and plug in the limit. You take the derivative, plug in the limit of the numerator and the denominator. It's that simple. Okay, so write that down. Pause if you don't have that because I'm moving forward to the next slide. And that is, let's do these 3 examples real quick here. So we're going to figure out first, do we have to use L'Hopital's? We can only use it if we get 0 over 0 or infinity over infinity. So let's double check here. If you plug in a 2 minus 2, that's going to give us a 0. You plug a 2 down here, okay, that's going to be 3 times 8. 8 times 3, 24. And then here you've got a 2 squared is 4. 4 times 6, that's a minus 24. You plug in a 2 here, you get a plus 2 minus 2, so 0 plus 0, so that is 0 over 0. We have to verify that it's okay to use L'Hopital. So since it is, we can go ahead and use this thing by saying we're going to take the limit as x approaches 2 of, okay, now take the derivative of this. This is going to be, derivative of x minus 2 is just 1. And the derivative down here on bottom, let's see, that's going to give us 9x squared minus 12x plus 1. Okay, now we can just take this 2 and plug it in. Let's see what we get. This is going to become 1 over 9 times 4 minus 12 times 4. What did I say? No, 12 times 2 plus 1. And I really should have tried to leave myself some room here. Boop. And then that's going to equal our final answer of 1 over 36. 36 minus 24 plus 1. This is really sloppy. 36 minus 24 is 12. 12 plus 1 is 13. 1 over 13. That is my answer. Look how awesome this was. You don't have to try to factor all this monster stuff. Just take the derivative of the top, derivative of the bottom, and then try the limit again. Okay, number 3. So you remember back in Unit 1, we did this stuff. You would have had to do, let's see, you remember you'd have to multiply the bottom by 6 and the top by 6. And then you can see that this right there is a 1, so the answer is a 6. Okay, that is true. So that's pretty fast and easy if you remember the special trig limits. But if you forget them and you're in a stump, well, let's just see if we can use L'Hopital's. If you plug in a 0, you get sine of 0. Sine of 0 is 0. Plug in a 0 here, you get 0. So since you have 0 over 0, you're allowed to use it. So now let's do the limit as x approaches 0, and then we'll take the derivative of the top. That's going to be cosine of 6x, and then chain rule, multiply by the inside, you get a 6 in the front. And then the derivative of x on bottom is just a 1. Don't get this confused with quotient rule. We're just taking the derivative of the top and then the derivative of the bottom. That's it. It's totally different than quotient rule for when we're doing L'Hopital's. Okay. And now we try direct substitution. Plug in the 0. So we're going to get 6 times cosine of 0 all over 1. Well, what's the cosine of 0? Cosine of 0 is 1. So you get 6 times 1 over 1. That just equals a 6. I'll write it here. Ran it out of room. 6. Boom. Done. And this one kind of looks like a trig limit, special trig limit. Let's verify first that we get 0 over 0. So let's plug in a 0. We get 1 minus 1 over 0 squared. So yeah, we're going to have 0 over 0. So we're allowed to use L'Hopital's. And let's do this. Limit as x approaches 0 of 1 minus cosine x. All right, derivative of 1 is 0, so that's gone. I still have a negative cosine x, so that's derivative of that's going to be negative negative. That makes it positive sine x. And then on bottom we have 2x. Okay, so now we try our direct substitution. And when we do that, we're going to end up with 0 over 0. So if that happens again, you just apply L'Hopital's. You keep going. So let's keep moving down here. We're going to have the limit as x approaches 0 of, derivative of that is cosine x. The derivative of this on bottom here is 2. And now let's try direct substitution again. Cosine of 0 is 1, and then we have the 2, so 1/2. So sometimes you'll see you'll have to apply L'Hopital's twice or even 3 times. You're allowed to just keep going as long as you had this 0 over 0, or remember the other option was infinity over infinity. Sometimes we'll have that situation as well. I have already mentioned this, but I want to really harp on it. L'Hopital's is not the quotient rule. Okay, so I bring this up because you're going to get so used to practicing with limits that you just do, you're just going to do the derivative real quick on top and the derivative real quick on bottom. And then because you'll get used to doing that, then we're going to go back and you'll have, once in a while, you're going to have a derivative of a fraction where you have this rational function where you have to do the quotient rule and you forget. So what I'm going to do in this lesson and in the packet is you're going to have some of these just randomly thrown in there in the packet to make sure that you're paying attention to when you use L'Hopital's and when you use the quotient rule. So we're taking the derivative of a quotient. So that means we go derivative of the first thing here. Oops, I started off wrong. So that derivative is going to be cosine of 6x times the inside. So I'm just going to put that 6 in front. And then you'll leave the second one alone, minus. And then we're going to leave the first one alone and get just sine of 6x. We don't touch that thing. And then you take the derivative of that one on bottom, which is just a 1. And then all over the bottom 1 squared. So that's x squared. That's the quotient rule. Can we clean this up a little bit? There is nothing really that changes. That's it. I mean, yeah, that's it. Okay, so that's quotient rule. So don't get it confused with L'Hopital's at all, please. Okay, last thing that I want to talk about. Man, this lesson was fast and easy. Probably the easiest lesson of the year. This is awesome. So if you have a situation where we have infinity over infinity, I talked about that, but I didn't really give you an example. That's because this happens when you have a limit where x is approaching infinity. Okay, so when x approaches infinity, if you think back to where we had end behavior rules, where you have this x squared over x cubed plus blah, 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 blah. So you just have to figure out which one's growing faster. That's what this is doing. So honestly, it's faster and easier if you just remember how to apply which one is growing faster or not. If you get an infinity on top and an infinity on bottom, well, which one's growing to infinity faster? The bottom is, so that's going to make this equal a 0. But you could take L'Hopital's rule, and just keep going. Let me show you real quick, and then I'll erase this. You could get 2x over 3x squared. If you plug in infinity, you still get an infinity. So let's keep going. If I get use L'Hopital's again, I get 2 over 6x. Now you plug infinity in, and you get 2 over a really super big 6 times infinity, so that equals 0. Okay, so it's still going to give you the same answer even if you use L'Hopital's. I know I did that fast. If you need to erase that part and listen real quick again. But it's okay to use it, but I want you to try and remember your rules for when x approaches infinity of a rational function, just top or bottom growing faster. Now these right here, we are not going to have to worry about this year in calculus. This gets more advanced. I wanted to throw them out there because it does involve L'Hopital's, and some of your textbooks that you might see around will talk about this. This is a more advanced calculus topic. We will not have to worry about this at all this year, so no stress there. Just making sure you understood that it was there. All right. And hey, we're done. So rock that mastery check, and that's the end of this unit.